Well, hello internet. In this video we'll be learning about creating hydrologically correct surface. To create this we will be also exploring the Topo to Raster tool of ArcGIS. This tutorial will be mainly performed on ArcGIS Desktop. So maybe in next video we can talk about how to do the same in ArcGIS Pro as well. Let's get started. I have some data, so I'm going to open my Topo data, and I have imported the data. So I have the Topo boundary, Topo clip, contour, elevation, and the hillshade, lakes, spots, and streams. So let's explore this. So these Topo spots are some spot heights that you see, and these are collected by field, by going on field as well. And then we have Topo boundary, where we see the boundary of our study area, and Topo streams. These are the streams data for topology. And we also have Topo contours. These are the contours generated or obtained from various sources. And we also have some lakes and Topo clip. Then we also have some data obtained from USGS, like Topo elevation. It's the digital elevation model of the same location obtained from USGS. And we also have Topo hillshade, so it's also the hillshade from USGS, but it's low resolution. It's 30-meter resolution hillshade. Now we'll be creating a similar digital elevation model and hillshade using Topo to Raster and inputting these features. How do we start it? Go to search and search for Topo to Raster tool. You'll find a few options. Click the one which is Spatial Analyst tool, Topo to Raster. And here we have the main tool open. Now we have some input features that we would like to use to interpolate and create a raster, a digital elevation model. So let's import Topo spots first. So these are the spot heights, right? What should be the type? It should be point elevation. It's not contour but point elevation. Then change the field. We want the elevation field to be used. So spot mirror will be working in the mirror unit. That's for Topo spots. Now we will also be adding Topo boundary. That's the next one. What is the type of this data? It is a boundary, right? So select boundary. Next, what will we be adding? Topo streams. What type of data is it? It's stream data. There we go. So as you can see, Topo to Raster, it accepts various types of data, and we can utilize all of them to get a proper high resolution raster. Then we also have Topo contours. What is it? The type is contour, right? And the field, it's not length, but we want the spot meter, the elevation field. Next, what do we have? We have Topo lakes. Okay, let's import that. And what's the type of this data? It's lake, so let's change the type to lake. And that should be it. That's all the data that we are going to use. We won't be using Topo clips. Now, where do we want to save the output? By default, it's going to save in my data scratch.gdb. because that's how we have set the environment. But let's change the name. Let's call it elevation. Elevation. What do you want the output cell size to be? Let's make it 10 meters. Output extent. If we have not changed it in our environments, the output extent, then we might have to choose an output extent, because it should be topo, like same as topo boundary. So you can choose here same as topo boundary, or if you like, you can go to geoprocessing and you know the drill, right? Geoprocessing environments, and change from there as well. But for this moment, for this example, we'll be changing here. Then margin in cells, let's leave it to default, and then we have smallest z values, largest z values. Let's leave those to default as well. Drainage enforcement, we'll change it to enforce, because if we have some like 3 options here. If we change it to no enforce, then what will happen? The sinks will not be filled. And enforce with sink, the sinks will be identified but not altered. But if we choose enforce, then it will automatically generate the sinks and also fill them. In fact, did you know that in type you also have the option of sink here? So if you have sink data, then you can input those and they will be filled automatically by Topo to raster. If you use enforce, then the sinks will be identified when during an iteration to generate the raster, and they'll be filled automatically as well. Normally we use the primary type to contour, so we don't really need to change it. It should be fine. And what should be the maximum number of iteration? Let's leave it default 20. Roughness penalty, let's leave these 2 fields to default as well, as it is empty, right? To learn more about this, you can always refer to the tool help. If this does not show, then you can click show help, and then this panel will show in your window as well. Next, we have a very important point, the tolerance. So what is tolerance 1? This parameter is important and should always be set because it controls the drainage enforcement and sink removal. The algorithm does not remove sink that are deeper than this value, which is the amount of systematic error in the input data in Z units like feet or meter. So in our case, what should we put in tolerance? Since we are using contour as well, we normally set the value half of the contour. What is the contour interval? I mean, half of the contour interval. What is the contour interval that we have? If you want to look, you can always refer to the attribute table of the contour, and if you see the meter, you see there is the interval of 12 meters between contours. So that's the average interval. So what should be tolerance 1? It should be half of it, 6 meters. That's how we can set tolerance 1. And for tolerance 2, verify it is 100 as it's shown here, so it should be fine. Now let's go to optional outputs. You can get more outputs if you want, like if you like the stream polyline to be exported as well, you can export that. Let's call it streams. If you want to get the sink points as well, you can get that one as well. If you input the name, then you'll get the output here. And then output diagnostic file, that's where you get the files, the log file, how each operation was carried out and how many iterations there were, how many sync points there were. That's the type of data you'll get in here. Let's call it something like diagnostics .txt. Okay, oh, we got an error because its default is txt, right? Okay, I think they should remove the error. Not within the defined domain. Okay, let's save it somewhere and call it txt. Save. Okay, it's working now. Then you can also have the output parameter file where it will list all the parameters that were used, and you have other options as well. So we won't be digging deeper into these options. One more thing to keep in mind is the margin in cells. What does this field do? It calculates beyond the boundary. We have already specified the boundary here, topo boundary, but how far beyond the boundaries should the values be used while interpolating. That's what it does, so that it results in more accurate DEM and more smoother DEM. So that should be it. Now let's click OK and start the Topo to raster tool processing. Let it run to the full. Nice. Now here we've got some outputs. Let me turn off others. So these are the three outputs. We got elevation. This is the elevation layer, and we've got streams, and we've got sync. So what are we going to do about this? Let's create hillshade. Let's go to first. Let's first go to this option and put the elevation on top of the table of contents so that we can analyze it better. You can turn on these features if you like or not. Okay, so now we are in elevation. We'll be creating hillshade and we'll try to compare with the one provided by USGS. So how do we do that? Simply go to search and search for hillshade. Hillshade Special Analyst. We'll use the input elevation as input layer. And what will we call it? We will call it hillshade, and everything else is fine. Just click OK, and this will generate a hillshade. Let's turn off all other layers except the hillshade and topo hillshade, because we are going to compare these two hillshades. Let's right click it and click zoom to raster resolution. Okay, done. Now we will change. You can see there's a difference in color between these two, right? That's because we need to change the stretch type from maximum minimum to standard deviation, because that's how it's done there. And also change n to, instead of 2.5, let's change it to 2. Press OK. Now we have both of them superimposed. What do we do now? Let's compare the default DEM provided by USGS and the one we created. Right click in the empty space, or you can always go to customize and toolbars as well. And then from there we will enable the effects toolbar. Okay, customize toolbars and enable the effects toolbar. You'll get this effects tool. Now select hillshade if that's not what's selected. Hillshade, and now we'll try to swipe. Here you can find the swipe button. Click it and let's compare by swiping. Right, as you can see, the difference in the quality in the spatial resolution. The raster that we created, it's high resolution 10 meter, but the one provided by USGS was 30 meters. You can clearly see that. Also, you can click Control and keep on pressing to clearly see the difference between these two as well, as you can see. So that's how we can compare these two. It's more, the detail is more visible in our hillshade. Now let's create hydrologically correct surface. How do we do that? We have this surface, right? While calculating, the Topo to raster tool automatically filled the sinks. It did, but still there can be some sinks that are remaining. Let's move the sink to the top, and let's turn elevation and sink on, and let's turn off all other layers. We see there are two sinks in our viewport. So let's fill those sinks. How do we do that? Search for fill tool. We'll choose the fill spatial analyst tool. The input feature will be elevation, input raster will be elevation, and output raster, let's call it elevation fill, and click OK. This will fill the elevation layer. This will fill the sinks and create a hydrologically correct raster layer. So that's it. That's how we obtain the hydrologically corrected topographical surface. We have obtained a hydrologically corrected surface. If we compare it with topo elevation provided by USGS, then we can see the difference. There's no difference, right? It's good. So that's how we create hydrologically correct surface. You can save this MXT file or export and get this data in your scratch.gdb. That's where all the data are. You can share them as well. Okay, thank you everyone for bearing with me. I hope this helps. Next, we will be learning about other GIS tutorials as well. Thank you for watching.